An example of computing the equation for a tangent plane is going to be that we want to find the tangent plane of z given by the inverse tangent, the function, not, tangent like we're talking about it, of y over x at 1 root 3. So this is our surface, z equal to inverse tangent y over x, that we might denote f of xy. And that's the point. And we know that our equation is z minus z0 equals f sub x minus x0, plus f sub y minus y0. And I've suppressed that evaluated x0, y0, z0 for both of these just to kind of save some space. So I'm given x0 is 1, y0 is root 3, and my z0 is just my f of x0, y0. So that's going to be inverse tangent of root 3, which is going to be pi over 3. So now I've got my x0, y0, z0. That's the point for my plane equation. Planes always need a point and a normal vector. The normal vector for a tangent plane is informed by derivatives. So let's go ahead and compute that. I need f sub x. That's equivalently dz dx. So that's d dx of the inverse tangent of y over x. And that's just going to be, let's see, derivative of y over x is going to be minus y over x squared. Okay. And then the derivative of, tangent would normally be 1 plus theta squared, for example, but the thing that goes inside is y over x, so that's just y over x squared. And I can try to simplify that, minus y over x squared plus y squared. And then my f sub y, I should start doing the y one first because it seems to be the easier one almost always. So that's d dy again of the inverse tangent of y over x. Again, I need a chain rule. The derivative of this thing with respect to y is just going to be my 1 over x. And then the derivative of inverse tangent is that 1 plus y over x squared. And it's 1 over x plus y squared over x. So that's times another x will give me x on top, and then I'll get x squared plus y squared on the bottom. Yeah, that should be fine. All I did here was I multiplied by 1 basically as x over x. So that became x squared, y squared over x times x canceled out, and then x on top. Just a little bit of algebra, not really necessary. But I knew I was going to have to plug stuff in. So I want to plug in x0, y0 to my f sub x. So that should be minus y sub 0 over x sub 0 squared plus y sub 0 squared, right? Where it's just these values that I plug in. So I've got minus root 3 over 1 plus 3. So minus root sub 3 over 4. And my f sub y is going to be x sub 0 over x sub 0 squared plus y sub 0 squared. So that's just 1 over 1 plus 3. So that's 1/4. So my equation, when I plug everything in, is z minus z0 pi over 3, I found that up here, is equal to f sub x evaluated at x0, y0, so that's minus root 3 over 4, times x minus x0, so x minus 1, plus my f sub y evaluated at x0, y0, so plus 1/4, times y minus y sub 0. That was root 3. And that is the full equation for the plane. You could simplify it, have z on the other side, whatever you want, but this is a fine place to stop. Just real quick warning about tangent planes. This last step where you plug stuff in is important. If you don't do that, you're going to end up with something that's not a plane. It'll have many more x's and y's hanging around than you're used to. So that's a good check that something went wrong. If you get to the end of this problem and you've got like x over x squared plus y squared times y minus 5, that's clearly not a plane. You forgot to plug stuff in. So just be careful about that.